Okay, in this section we're going to be talking about real numbers, square roots, and order of operation. So we're going to understand what a real number is and apply the order of operations and do some application problems. I am not going to talk about approximating a square root because I know most people are going to use their calculator. You can look in the resources for that if you want to know how to approximate. Alright, so we're looking at real numbers, and I just wanted to remind you, we've looked at this picture before. The natural numbers are just 1, 2, 3, 4, 5, does not include 0. The whole numbers include 0, so it starts at 0 and goes 0, 1, 2, 3, 4, 5, so all this adds is 0. The integers include all of the negative whole numbers, basically, so negative whatever all the way up to positive, but just whole numbers. The rational numbers are fractions that can be expressed with an integer on the top and an integer on the bottom. And when you put them in your calculator, you end up getting a repeating decimal or a terminating decimal. And the irrational numbers are everything else. So I've got that summarized right down here. A rational number can be expressed as a fraction with integers on the top and bottom, or it can be expressed as a decimal that it's going to repeat or it's going to terminate. If it goes on forever and ever without repeating all the way to infinity, it is irrational. All right, if the square root of a whole number is not a whole number, it is irrational. Okay, so an example of this is going to be, if I take the square root of 25, then that's just 5. That is a rational number. If you take the square root of 26, that is not a whole number. I don't know what it is, but it's not a whole number. It's not 4, 5, or 6. It's going to be irrational. So that's just a really simple rule to remember. All right, the next thing I want to do is talk about all of the places that these numbers, the categories that all of these numbers fall into. All right, the first number we're looking at is the square root of 11. Well, it doesn't have a perfect square, so that one is irrational. So that one's pretty easy to figure out. So the irrationals with square roots are fairly simple. All right, negative 2 over 3. So negative 2 over 3 is not a natural number. It's not a whole number, and it's not an integer. So it does fall into the rational number category, because when you put this in your calculator, it doesn't matter actually if you put it in your calculator, but you will get a repeating number. But the other definition is that you've got an integer on the top and an integer on the bottom, so it is a rational number. So this is negative 2/3 goes here. All right, the next one is 0. 0 is not one of the natural numbers. If you look at that list we were just looking at, you'll see, if you don't remember, that it is not a natural number, but it is considered a whole number, which means it's also an integer, which means it is also rational. All right, so that's, now we've gotten rid of, now we're at 4.2. 4.2 is not a natural number, it's not a whole number, and it's not an integer, but it is a rational number because it is a decimal that terminates. So that's considered a rational number. All right, square root of 9 becomes 3. So that means it is a natural number, so square root of 9 is a natural number. It's also a whole number, and it is also an integer. Which means it's also a rational number. Okay, so the next thing we're looking at is negative 13. Negative 13 is not a natural number or a whole number because those don't include negatives, but it is an integer. So this is negative 13 right here in the integers, and then that means it's also a rational number. All right, the next one is square root of 16, and remember square root of 16 is just 4, which means it is a natural number, it is a whole number, it is an integer, and it is also rational. All right, why don't you try these next 4 and see how you do, and then come back and see where they ended up. Okay, so you can see where I put them in green. 3/4 is a rational number because it's an integer over an integer. Negative 3.1 is a terminating decimal, so it's a rational number. Square root of 19 is irrational because you don't get a whole number when you take the square root. And negative 8 is a rational number and an integer. Okay, so next we're going to talk about applying order of operations to numerical expressions that have decimals in them. One thing to know is that square root and fraction bars are grouping symbols. So this is considered a grouping symbol, and this is considered a grouping symbol. Okay, so for starters, we're going to start with A. We get negative 3.2 plus 5 times, now we want to take 4.1 and subtract 0.6, and we get 3.5. The next thing we're going to do is we're going to multiply these two together. So we get negative 3.2 plus 17.5, and that gives us 14.3. All right, the next one, remember, we want to treat the square root as a grouping symbol and do that first. So we've got negative 14.8 divided by the square root of, when you subtract those two, you actually get 16. So we get negative 14.8 divided by 4. So when we do that, we get negative 3.7. All right, the next one, remember we treat the fraction bar as a grouping symbol. We're going to do the top, and then we're going to do the bottom, and then we'll take care of that last step of dividing. So remember the fraction bar is also a division symbol. All right, so on the top, I just wanted to remind you there is a division symbol right here. That happens before the plus symbol. Okay, so make sure you understand that that happens first, and if you can't remember, put parentheses around it, and that'll help you remember. Okay, so we've got 0.6 plus 2.7 divided by 3 is 0.9. Sorry about all the things constantly popping on my screen. It doesn't matter how much I tell it to stop, it just keeps doing it. 0.6 plus 0.9 over 0.03 times 1,000 means we take the 0.03 and move the decimal place over 3 places to the right. So we're going to go 1, 2, 3. We're going to have to add a 0. So this gives us 30. So we get, this becomes 1.5 over 30. So 1.5 over 30 is 0.05. And don't be shy about using your calculator on these. Your calculator does not always get the order of operations correct. If you don't put it incorrect, it doesn't give it to you correctly. So make sure you understand how to do it. All right, there are 3 try-its here that I would like you to do. I'm going to pause the video and I'm going to write them all down, and then you can check your work. Okay, the answers are up, and you can just pause the video again and check all of your answers, and I tried to show every single step. Make sure you understand that when you have 0.272727, you can just write it as 2.27 with a bar over the 7. So it needs to be one big bar over the 2 and the 7 because they're both repeating. And down here, don't forget that the 38.6 divided by 10 happens first because that's order of operation. The last 2 problems I have for you are examples that are from or similar to the problems in my lab. So I wanted you to see a couple. So this first one says to evaluate the expression for x equals negative 4.5 and y equals 4.1 for this particular equation. So all you have to do is plug everything in just like you've done in the past. We've got 10 times 4.1 minus 30 over x is negative 4.5. So the hardest part of this is the order of operation. So you just need to make sure and do it properly. 10 times 4.1 is 41 minus 30 over negative 4.5. And that is going to be 11 over negative 4.5, which should give you 2.44444, negative 2.4. It goes on forever. And so what you want to do is you want to write that as, if it asks you to round it, then you want to round it to whichever place it says. If it doesn't ask you to round it, you can write it as 2.4 with a line over the 4. All right, the next problem is just giving you a formula for finding a car's gas mileage. That is that the mileage is the ending minus the beginning over the gas used. So the mileage is the ending minus the beginning odometer readings all over the gas mileage. So if you've ever figured out your gas mileage yourself, this is how you do it. So, and this is how you used to have to do it before they started making fancy cars that figure it out for you. So we've got 38,989. We've got some crazy things happening with my iPad right now. I don't know why, but 38,989.5 minus 38,423.1 all over 19.2. And you're going to subtract the top, and then you're going to divide by 19.2. So you should get 29.5, and that's 29.5 miles per gallon. All right, thanks for watching. See you in the next one.